Looking at mixed exercise 6, question 4b is the one that someone's asked me to do. Let's have a look then. So it's solve this equation in the interval 0 to 360. Now, a couple of things that we notice first of all. First of all, I've got sec and cosec. I don't have sine and cos, which I feel more comfortable with, but that's fine. We can deal with a sec and cosec. Secondly, I have got 135 here. Now, 135 I'm recognising as an angle which is 90 degrees plus 45 degrees. So that is something that I could find the exact value of if I need it. And also this is just a number here, right? So it looks nasty because it's cosec of something nasty, but that's not a problem. It's this side where I've got a problem. Now I've got sec of something, take away something else. It only just occurs to me that also we're doing this as part of chapter 6. I might look at this, and you might be looking at this and thinking, oh, well, sec is 1 over cos. And now use the cos A plus B formula from the start of chapter 7, if you've looked at that chapter 7. And we can't do that because it's a chapter 6 question, so there must be another way of doing it. Fair enough. So I'm also noticing that the 15 is, that's the gap between 30 and 45 and the gap between 45 and 60. So that, kind of exact values of triggered entities might be something which is going to help me out here, okay? So I think I'll think of this as 1 over cos 2 theta minus 15 degrees equals 1 over sine of 135 degrees. And then I've got everything as sines and coses now. I'll rewrite that again like this. Just makes me feel happy about it. I've got sines and coses which I can deal with. Now sine starts at 0 and goes like this. So here is 90 degrees, here is 135 degrees. So the sine of 135 degrees is the same as the sine of 45 degrees. So sine of 135 degrees is root 2 over 2. And I know that one because that's one that, sine of 45 degrees we should know, right? So cos of 2 theta minus 15. And look, now I'm suddenly into a year 12 technique, right? So cos of something, this is a linear expression, equals a number. So it's not as hard as we thought at first. The way that I teach people to do these ones is, and again, I'm not going to go through this, it's a year 12 technique, so I'll get you to go back and look at that. But I would say let big X equal 2 theta minus 15. So cos of big X, solve for big X, and then turn your big X solutions into theta solutions. But don't forget that when you change the variable from theta to big X, you've got to change the limits. So you're not solving between 0 and 360, you're solving between different values. So we're into a year 12 question from there. Part 2, B part 2, is asking us sec squared theta plus tan theta equals 3. And I'm looking at this and I'm thinking, I've got a sec squared and I've got a tan. Now I know there's a link between sec and tan. If you are like me and you don't like memorising formulae, then cos squared plus sine squared is identical to 1. You at least need to be able to get there from here fast, okay? So I know that that is 1 plus tan squared is equal to sec squared. Because I divide through by cos squared, divide through by cos squared, divide through by cos squared. So sec squared I can turn into a 1 plus tan squared. So this equation here turns into 1 plus tan squared theta plus tan theta is equal to 3. And now I could legitimately stop here because we're into a year 12 question. I'll just go a little bit further. So that's 2 equals 0. This is a quadratic in tan theta. So I'm gonna write t equals tan theta. This is t squared plus t minus 2 equals 0. I'm going to solve that for tan theta, and then back into that year 12 technique. I suppose I can do this, can I? I can factorise this one. So I get a 2 and a 1 and a plus 2 and a minus 1. So I get tan theta equals minus 2, or tan theta equals 1. So solve that in the interval required and solve that in the interval required, and we're back into year 12, so I'll pass it over to you.